my Git tree with sending everything on to Linus Torvalds. That's my main area of work. I'm also in the kernel team at Linaro, and in both of these jobs, I'm always wondering what we do about the really low-end system. I have to say I'm not an expert on this, and I'm hoping to talk to experts today. I did a little bit of research. I'm presenting my opinion, my findings about those systems today, and then we'll have a second half of today's session talking about where we need to be heading in the future. So the main question for us today to answer is, what kind of really small systems are we actually interested in for Linux on ARM, and which systems do we say we don't care about running Linux on those, or we don't care about using ARM CPUs for those even if you're running Linux? I tried to find a small collection of machines that are considered small machines running ARM Linux today. Most people think of phones as a small system. If you look at the Sony phone here, use that for Tim. That's like a high-end phone. It's actually got 3 GB of RAM. So that's the same amount of memory that you have in a Chromebook or a cheap laptop. It's not actually a small system. And even if you go to the very low end of phones that you can buy today running Linux, for $33 you can get a phone that has 128 megabytes of RAM. That's still not a particularly small system, even though it's one order of magnitude smaller than this one. To go to what was actually an embedded system in my sense, you would have to go to something like this, that is even one more order of magnitude smaller, using 16 or 32 megabytes of RAM. So these are kind of small systems that people are using on a large scale today. And 32 megabyte, interestingly, seems to be a sweet spot for embedded system, has been for a long time. And I tried to figure out why that is. So if you look at it, this is basically the only system with less than 16 megabytes that I could find, and that didn't really do anything and nobody bought it. What you need to do to scale down from a typical Linux system to something that runs in as little as 32 megabytes of RAM is you have an embedded distribution, something like OpenWRT, Buildroot, Open Embedded, things like those. You run just a BusyBox user space. You have very little user space. You can have a full distribution there. OpenWRT, you can download binary packages. It feels almost like a Debian system. You can do a lot of the same things, but everything's smaller. And the typical system has something like 4 megabytes of flash, 32 megabytes of RAM, and a ARMv5 CPU. That's a very typical thing that you find in lots of different markets, whether it's in a Wi-Fi router or even an SD card that I had on the previous picture. So this is an SD card with Wi-Fi controller in it. It actually runs in ARM Linux. It doesn't get much smaller than that in physical size. So this space is fairly well known. One interesting thing that surprised me while looking at that is this is actually the cheapest configuration you can get to. If you try to buy a DDR2 memory chip, you can't get anything smaller than 32 megabytes, and anything older than DDR2 is going to be more expensive, basically.
Cheapest with DRAM. Cheapest with off-chip DRAM.
With off-chip DRAM, yes, exactly. But SRAM tends to be more expensive for the same size. So so this seems to be a sweet spot for this case. Another interesting point here is this will keep growing in the near future, because as people are moving to DDR3, the smallest size you can get is suddenly 128 megabytes of RAM. so 4 times that. And people are also moving from NOR flash to NAND flash in the same areas for the same reasons, for price and getting with the times. And then you go from 4 megabytes to 128 megabytes of flash, and suddenly you have completely different constraints, and flash size suddenly isn't one of them anymore. So people are doing this basically to get the cheapest system that you can run on connected to maintenance power. If you're not running on a battery, this is what you would use. And you can build a system for a few dollars at most. But you can get smaller than this. And at this point, you're not actually saving any money anymore. You wouldn't do this for cost reasons normally. You can get down to 2 megabytes. The reason for this is you run on a battery. You don't want to charge the battery every other day. And then you want to use SRAM, which is more power efficient. So instead of having a DRAM chip next to your SoC, you have an SRAM chip next to your SoC. It's 1 order of magnitude less memory, and also an order of magnitude roughly less power consumption. But if you do this, you have a lot of new constraints. Typically, those SoCs you would use for this don't have an MMU anymore, which is a huge pain to deal with in Linux. And RAM, if you're going to SRAM, size suddenly becomes a huge cost. If you want to go to many megabytes of SRAM, it's basically the largest cost for your machine. You want to reduce it as far as possible. If you go to 2 megabytes of SRAM, you can't really do software field upgrades anymore because everything is running from flash. You have the kernel in NOR flash executing directly from there. You have a little bit of SRAM, and you typically have just one application program running the whole time. You don't have a distro in that sense anymore. So this is what you do for for power reasons. But you still have a system where you need to have at least 2 chips. You might have a small SoC that does all the things, and then you need to have the extra RAM chip that is much bigger than your SoC and much more expensive. When you go 1 order of magnitude smaller, you get to the really silly kind. You have 256 kilobytes of RAM. That's the smallest system that I have heard of running Linux on an ARM CPU. Italy Wool from, is he working for Sony or is he contracting? Or?
Well, he contracts with Sony. This was for his own consulting.
Okay, so he's shown that it's actually possible to do a Linux running in 256 kilobytes of RAM. I would never have thought that possible. He did it. He did a highly hacked up kernel. You won't be able to do that with an upstream kernel, unlike the previous ones where you can actually run a mainline kernel today on an EFM32 without any patches in 2 megabytes of RAM. You still get much lower power consumption. You have 1 tiny chip that you need, and everything runs in that chip because it contains both the flash and the RAM and all the I/O you want. Both user space and kernel are running from flash, and only the very like the data section of your kernel and very few pages of user space are in RAM. You know exactly what you're doing. There's an incredible amount of work getting this to run, and I'm not sure that with 256 kilobytes you can actually do something useful. But just showing that it's possible to do this, you know that if you add a little bit more RAM, you can actually add something valuable to it. So this is the absolute minimum that I'm aware of running Linux. But you can ask, why do we actually want to run Linux on this kind of system? Because most of these microcontrollers are meant to run real-time operating systems of some sort that are very tiny kernel, and you link the application directly into the kernel. But they have some significant disadvantages as well, at least from the perspective of a Linux developer, as I am. I know Linux, I don't know any of the other real-time operating systems or any tiny kernel, so it's much easier for me to get used to it. And a lot of you probably have experience with Linux and don't have experience with any of the other operating systems. You would consider running on it. So if it's your task to get the system to run, Linux would probably be the first choice. Then there's the driver support. We have all sorts of device drivers in the kernel already. For another operating system, to probably have to write your own driver. And then we have a network stack that is mature and tested. And I'm very afraid that if we are going to see millions or billions of devices with a random real-time operating system and network stack that has been hacked up by whoever developer was tasked with this and then never updated because you can't update that, would have an endless amount of security holes in the long run. So this is a huge risk that you have if you use an operating system that doesn't have such a wide install base or a mature network stack. And of course, the disadvantage is Linux is essentially much larger than anything else you would consider. But the question we'd have to ask ourselves is, we know that below a certain size, we don't want to run Linux anymore. We know that above a certain size, we almost certainly want to run Linux on a microcontroller or on a bigger machine. But what's the limit? You can ask a similar question about the CPU. There are lots of CPU architectures in the world, and almost all the Linaro members that make an ARM SoC also make an SoC with a different CPU architecture, and some of them may be better suited for it. For example, in MIPS, you have very small cores, similar to Cortex-M, but they have an MMU. That makes it much easier to run Linux if you have slightly more memory, because you need about 100 kilobytes just for the memory management code in Linux. If you have 100 kilobytes, it's immensely useful to have it turned on. But still, ARM is basically taking over all the markets where processors and SoCs are being used at the moment. The other CPU architectures seem to be going away slowly. So it would be nice to use ARM for those. And it used to be fairly popular in the past as well, so we should be able to do it in the future. So I've looked at the kernel code where we are regarding ARM, NOMMU-Linux in particular, because that seems to be the main thing about the really small systems going below 32 megabytes and the Cortex-M instead of an ARM9 or Cortex-A5. We have the ARM7TDMI that is currently used in the AT91X40 SoC family. It's been working for probably 15 years. It's been supported upstream, and we're just about to throw it out in the next release or the one after. We're supporting lots of CPU cores in the kernel that don't have an MMU. You can build the kernel for those CPU cores, but we don't support any SoC that has them. So there's a question, what good does it do us still keep supporting those CPU cores? And anyway, everybody who is using an SoC with any of these cores is probably using the 2.4 kernel from the UC-Linux distribution. So we support it all upstream in 2.6, and we're still supporting it in 3.0, but for some reason the users of these chips have never moved beyond 2.4. For Cortex M, for a long time we didn't support it at all, so everybody using it was on a vendor kernel from based on a 2633 kernel that ARM did initially, and that was picked up by some companies. A lot of people have products based on this. We never had anything upstream until Pinketronics contributed a port for the ARM7TDMI SoC. That's been supported now and seems to be working well. And you can build incredibly energy efficient systems with this SoC. The same should, in theory, be possible with a dozen other microcontroller platforms that we don't support upstream. And then finally, we can support NOMMU kernels on CPUs that actually have an MMU. You can, on most SoCs we support today, you can turn off the MMU and you can still run them. But apparently nobody does that, and I'm not sure there's a good reason for that. But one of you might come up with a good reason why it's needed. If nobody has a good idea what it should be useful for, then we could probably just remove that support. I also looked at the size growth, like how much harder has it become to run Linux on a really small system. And I just looked at the kernel code. Back in 2616, the smallest configuration you could have on ARM was around 650 kilobytes for a kernel that didn't do anything at all. Default configuration was around 2.4 megabytes. And in the 8 years since, the minimum configuration has hardly grown at all. It's still less than 800 kilobytes, so it's grown some 15%, maybe 20%. But the default configuration has grown quite a bit. It's over 4 megabytes now, which means we've added a lot of features. But if you want to use those features, of course, you will have a much larger kernel that might not fit into the device into which it was fitting in at the 2.4 or early 2.6 time frame. So that's it for my presentation, and now I think we should start the discussion. Yeah.
Arnd, you talked about the default config. Is it the case that there are many built-in things that have been made options now, so that the minimum kernel size being consistent might not reflect?
Yes, that's probably one point. I haven't looked at that in detail. I know that the block layer and the TDY layer used to not be optional, and they now are. I'm not sure if 2616 already had the optional block layer. It didn't have the optional TDY layer. And I know that at some point the kernel actually got, the minimum configuration actually got smaller. So this 2632 was actually smaller than 2616, and that may have been an effect of the block layer becoming optional based on the work that they found. So it might be that the larger kernel today actually does less than the smaller kernel in 2616 that did. So let me just see, show of hands, who has used a system with ARM Linux without an MMU in the last 5 years? Is any of you still using that? No, I mean, is anybody working on products that are using this? No? Okay.
We might have a little bit of that question.
Yes, I was hoping to get that audience here, but maybe we just don't have those people in Linaro Connect.
So, you may have asked the wrong question. So,
yeah.
Okay, this is a terrible thing to admit at a Linaro event, but we have used, Sony is working on a wearable with a MIPS core in that range.
Mm-hmm. And is that for the reason that I mentioned, that MIPS has an MMU in the low-end cores and ARM doesn't?
I don't know the details on the sourcing. I just know that we've got a MIPS core in one of our wearables.
Yep. But that's a very useful piece of information, I think. Because it seems that ARM is moving more into the higher end markets, and maybe that we're just abandoning the lower end, not just in Linux but everywhere. Yeah, I mean Cortex-M is still there, but it's still getting bigger.
I should add that device I'm referring to is not running Linux today.
Yep.
This has an MMU. It's got an ARM7TDMI, so but the code running in there is not using the MMU, it's just turned off.
Oh,
Well, actually, it's turned on for the caches, but it's using an identity micro.
so the systems that I looked at on the first slide, which of course didn't see, there was the SD card with the Wi-Fi that has an MMU in it because it's an ARM926. The only system without an MMU on the slide was the Apple iPod, which of course did not run Linux officially, but people managed to get Linux running on it.
So I think a lot of the systems that don't have an MMU, the reason that they don't have an MMU is the latency guarantees rather than low power guarantees. And typically on those systems, Linux is the operating system they choose because they have some hard real-time deadlines to meet.
Yeah. So one of the problems with the ARM architecture that I see is that we have those three profiles: Cortex-M, ARM7, R, and A. But you can't just mix and match features from those. So if you have a Cortex-M, there's a lot of things that you can't have, and if you have Cortex-A, you have to have them all. So you can't just have the tiny core that leaves out everything except for the MMU.
It's also going in the future, there are probably going to be more systems where the M's and the A's are clearly present in the SoC. So you could have, I know already a handful of systems where the Cortex-A's are paired with Cortex-M's for power management, for example.
Yes, but the Cortex-M is not running Linux in that case, and then that's not part
running?
of
Could
discussion.
it be not running?
Huh?
Could it run Linux?
Well, it could, but you wouldn't.
It goes back to your first slide.
Yeah. Yeah, that's true.
And I know Nicholas is a
Especially if
big
it
fan
has
of
access
running
to the memory that's already
firmware
there.
like into Linux. So.
Yeah.
So it seems to me that, as you say, people aren't doing this much anymore, but all the Internet of Things people probably ought to, and there's lots of that. It is happening. Are they? I mean, is that the thing?
The guys at work using IMX6.
Right. But if you want to make cheap sensors, then you actually want to get this running on the piddly things. And as the man says, if our network stack's crap, it's going to be a nightmare. So it seems like a good reason for keeping this stuff working. But
Well, yeah.
I don't know who's actually doing that and whether they are or not.
The problem with the Internet of Things is that there's an awful lot of things out there. And a lot of those things have an MMU and others don't. Yeah.
New list of operating systems.
In your list of operating systems, I didn't see you mention TinyOS. Did you take a look at that?
No. As I said, I'm not actually an expert, so I did my own research and I didn't come across that one. So that's Yep. And I didn't list any non-open source systems. But I guess if you mention it, that it is open source.
I was wondering why on that slide that had all the pictures of the machines, you included a 3 gigabyte memory machine. Is it?
Yeah, well, the reason is that
a lot of people, that's a very high, for a cell phone, that's still a pretty high-end machine.
Yes, the reason that I
was there.
gave it as an example is that when people think of small systems running Linux, the first thing that comes to mind is phones in a lot of cases. I want to show that this is actually not that small.
Oh, okay, all right, no, because all the other ones were like, which you think, 128 meg or less.
Yes, I looked
3 gigs sitting in the corner, and I just wondered why.
Yes.
It was lumped in with those. I think it was more for contrast.
Yeah, as I said, there's with phones there's already an order of magnitude difference, but even the smallest one, that's an order of magnitude smaller than the largest one, is an order of magnitude larger than the typical small systems. When's the last time that anybody heard about a machine running an ARM7TDMI?
Like my iPod,
Yes, but I mean something shipping with Linux. Does anybody think we should keep ARM7TDMI support in the kernel after we remove the 89.1?
So I would say that it's not the CPU support mode, which is the burden, right? It's a pretty self-contained file.
Yes, but
the thing that could cause the burden is the architecture, so supporting V4. Moving that with
but that's
then you include a whole lot of other platforms which do have users. So supporting the core is the end of the
yes,
Yeah, there's
that's
still V4 devices, well, certainly V5 stuff.
Oh, yes, yes, yes.
That still exists, and people are still making them. So.
V4 with MMU is certainly still in use and used a lot, and people are actively working on adding new ones.
What should we say?
No, we wouldn't save any significant amount of lines of code for removing that one. What I'm interested in is reducing the test matrix, because currently when you're building a kernel for ARMv4 without MMU, we run into dozens or hundreds of build time errors in random configurations, because nobody tests it.
Should we move the ARM7TDMI to a configuration that is also more?
Well, I'm testing random configuration, so it will still be enabled. The only thing that would help is if it's impossible to enable. We could keep the code around, but this depends on broken, because we know nobody's using it. But then what's the difference to removing? If we come to the conclusion that nobody has been using this for at least 5 or 10 years, and I'm assuming that even on the iPod you wouldn't run a 3.17 kernel. Yes, exactly. And if that's the case for everybody, then we can just remove it.
I know about new designs using that ARM TDMI chips into door controllers for one-matching trains. The thing is, they're using a 2.6 kernel.
They're using what?
A 2.6 kernel.
Yes, and what's the chance of them ever upgrading?
Never.
Yes, exactly. And my impression is that this is the case for everybody.
I think the question you're getting at is here, and for our membership especially, is, okay, we've got these old platforms, and we have the question, do we keep supporting, do we not keep supporting them? But moving forward, what's the level of interest in small systems running Linux, especially with IoT and deeply embedded systems?
Yeah.
What do we focus on that in both the community and with Linaro, or do we say, Linux is maybe not the choice that most people are going to make in that environment, and just not worry about it too much?
And the same question, I'm really interested from both sides, from both the upstream perspective and from the Linaro perspective.
This is just a special case of a more general problem where you've got processors, you've got drivers, you've got functionality, you've got maybe certain config, tunable parameters, etc., that are sort of well beyond the normal range of usage or haven't been used for a long time. And the question is, when should you or could you retire them and say these are no longer supported? On the other hand, once you stop supporting them, I imagine it would be almost impossible to start supporting them again, because them to get back in, it would have to work. Right now they're in sort of a grandfather flavor where they don't really work, they're almost there for reference. Would you agree or disagree?
Yeah, so this is generally a problem, but usually the rule is we remove something when we think that nobody is possibly using it anymore, or it's broken and hasn't been working for a while. But if anybody complains and says, I still need this, and this was actually working for me, then we put it back in the state it was before.
I'm actually the marketing of it. If you have a 2 megabyte kernel and you're arranging to fit in 2 megabytes of SRAM, I think the people you are serving with that are people who are making low volumes. They're the ones for whom the list of benefits of Linux, the familiarity, they're not able to train on new tools, the low-cost development cycle is what you're describing, is particularly important in markets where you don't hit the volumes to pay back your non-recurrent engineering. And perhaps the Linaro members, by nature of being much larger bodies of organisation, would prefer to drive the cost down further, because they're making higher volumes, at which point they'd rather have 1 megabyte of SRAM and not run Linux. See what I mean?
Right, but as far as I know, for example, ST Microelectronics has people doing Linux on STM32 SoCs.
I did ask somebody to look up on that, but I didn't get an answer.
Yeah. And STM32 is actually the platform used in the example with 256K, and this is also what a lot of people use commercial Linux on 2633 kernels from companies.
Well, yeah, because the cool thing about the drivers is that what you quite often see, especially at low volumes, is that USB-based parts are much cheaper. So a Bluetooth USB part is very, very cheap. A Bluetooth microcontroller part is extremely expensive. So to have an operating system with a USB controller built in allows you to drive down the cost of some of your wireless connections. It's quite a peculiar phenomenon. So having, and modern microcontrollers have now got on the go with controllers. So.
And if you can run everything from one chip, it actually fits in the USB connector. So I was hoping we could get some real conclusion, but I didn't have high hopes on some of these. Yes.
So one question from sort of a community perspective is, so we know that there are these, there are people out there who are using Linux and small systems, but they're stuck in old kernels. There is no incentive for them to move to a newer kernel. What could the community do to incentivize them to move to a more recent kernel? That's, I think, is one question to consider.
One time, when we first started with digital Unix, it required 64 megabytes of memory just to boot the system. And the product managers required it to cut down to 32 megabytes because it was considerable savings at that time. The engineers did the work, but what we found out was the system ran about 7% faster because a lot more of the kernel and various parts of the system fit into cache. So even though we have very large main memories, our caches are still relatively small. We might find a performance improvement in that.
If everything runs on the 256 kilobytes of SRAM, then you never have cache miss.
I think to follow on from that, we mustn't confuse having a small kernel with having a NOMMU kernel.
Yes, that's
because we seem to be doing that a bit, and the point is that the NOMMU crowd aren't engaging upstream, and I'd certainly love to fix that, but there's a whole different mindset for the people making NOMMU systems.
Exactly. Yes.
But making a kernel smaller, there's loads of people that want to do that, and even the x86 guys are interested in doing that as well at the moment.
Yes, but there are different reasons for making the kernel smaller, but one thing that I mentioned earlier is that this is becoming less and less interesting if you actually have DRAM. And if you don't have DRAM, you most likely don't have an MMU on ARM. So in theory, there should be completely separate issues, but in practice, they always come together.
So the problem with the expanding kernel is for new systems, it doesn't matter. But if you're upgrading existing systems,
yes.
The problem is that the boot space allocated in your NOR or whatever, which you can't easily change for real systems for actual consumers, the modern kernel simply don't. So we've had to drop platforms in Debian because the kernels simply don't fit in the boot space anymore. So we go, well, there's not much we can do about that, sorry. Which is actually quite annoying because there's nothing broken, it just doesn't fit anymore. Yes. And you have to keep basically the same functionality. You drop things for a while until you go, well, there's nothing we can really leave out and still have this called an equivalent kernel. So I'm not sure what we do about that, but yeah, obviously things designed 10 years ago went, 256 mega boot space is loads.
And an interesting observation that I made when looking at OpenWRT is they actually have patches that make the kernel runtime size larger in order to make the compressed kernel size smaller so it will fit into the flash, because they're much more constrained on the flash side, the compressed size of the kernel than the runtime size.
I assume that the sort of opposite question is a non-starter, which is convincing ARM to, in this day and age, make something that would take small amount of memory but have an MMU. I assume they would have no interest in building something in this day and age.
Really. There are low latency real-time cores where MMU doesn't make sense. And then there are cores, the A-class cores, which have an MMU, but the CPU will work happily with 1 megagram. It's not a hardware.
Okay, then why are those not being considered?
No, but if you have a Cortex-A, you can't get into the low power stuff because the smallest core is Cortex-A5, and that's just so much bigger and has so many more features than the Cortex-M3.
That's not necessarily the MMU's fault.
It's not the MMU's fault, but you can't separate one from the other. You can't you can't have a smaller core that's still smaller than the A5 or much smaller than the A5 and still have an MMU, because as soon as you,
it's like low power, low memory, MMU pick 2 out of the 3.
Yeah. About power, what do you mean? Runtime power or system power?
both. I think for most people it's suspend power, but runtime power is a different issue that may be more important for other people.
I think the system power is not getting hard.
Okay, that's it. Okay, interesting. Can you pass the mic?
So you may have already addressed this. I thought you said something about it, but like TI just recently did something with an on-chip DRAM that was like 2 meg, which I thought was interesting. So I don't know how that factors into the kind of the lowest price DRAM is 32 meg. I think you said something earlier about these on-chip ones are kind of specialty solutions and they're not less expensive than the external DRAM ones.
Yeah. So I guess in this case they would also have the DRAM being power optimized would also be a factor. So in that sense it wouldn't be all that different from SRAM or PSRAM. It's just
the original picture, the device that is still RAM that is persistent. It's quite likely that it's
yes.
Probably 16 meg.
That may be a game changer too, because if you have persistent RAM, it doesn't consume any power at runtime or at idle time.
You have to fit.
You have to fit, yes, but if you have 16 megabytes, yeah, it's not that hard today, but it will get harder over time, of course, yes. And that may still be something to optimize for. Another point with the, similar to what Maddox said, like making the kernels, the system smaller makes it also can make it sometimes faster. We sometimes have regressions where we introduce a bug in the kernel build system that makes the kernel both bigger and slower because we made a mistake. And just being better at finding size regressions means we can also catch this kind of regression where things suddenly turn slower because someone did something stupid. We just had one of those cases in the FIS-to-Vert address patching, where a lot of users of the code that did a computation that would normally get simplified by the compiler, but as soon as we did the patching, we got this extra computation. Like the code actually got a lot bigger by a patch that was meant to make the kernel smaller.
I don't know what problem you're trying to solve.
Sorry,
I don't know, maybe that's subject like that. What problem are you trying to solve? Simply a couple of problems, or several. One's the no MMU crowd who are always forked and never come back. And then there's is it worth making the kernel smaller because it just kind of tends to grow over time? And then there's do we care about all systems and code lying about?
Yes.
And I think the conclusion to all code lying about, as long as it's not hurting anybody and it's not very big, who cares? So, is there any conclusion to any of this discussion?
For me,
Not really.
Okay. We discussed it earlier, but I think the important thing is actually doesn't have to do with ARM or Linux. It's the fact that we may face 9 billion insecure network nodes in the future if we don't do something.
Yes, that's yet another problem.
Making the kernel smaller is what we can do.
Well, if we make I don't know. Who knows if the 9 billion nodes are all going to be, with only 2 meg of RAM.
Yep. My view is A-class ARM cores will be used in, my view for what it's worth. A-class Linux ARM cores, A-class ARM cores will run Linux, will be an Internet of Things. There's a percentage at the top that just will. And so it's probably worth pandering to
Using DRAM.
Yeah, whatever. They're going to be constrained systems with MMUs, not the rest. And there's going to be an awful lot of ARM processors, M-class, R-class, without MMUs. So do you care enough to want to run Linux? the solution will be open source. Will it be Linux on those? Don't know. Yeah?
Depends if we make it attractive enough, doesn't it?
But the other question is, if someone asks us, well, can we improve support for Linux on the Cortex-M? Do we tell people use Cortex-A? Do we tell them to use something other than ARM? Do we tell them to use something other than Linux?
Well, not to put too fine a point on it, but right. So is ARM disincented to solve this problem?
Yeah. At least one thing that I got out of this so far is nobody seems to object to the idea of removing the support for really old architectures with no MMU.
So I don't mind the architecture thing, really, but I think removing 100 lines of code that's not TDMI is just ridiculous.
No, it's not about the lines of code. It's about the test matrix.
We'll do that. I mean, you could say it's just supported on a best effort basis. Yeah, that's fine to do. Yeah, I agree that testing.
Yeah. So one of the work that I've been involved in over the last 1.5 years is trying to get random configurations to build cleanly in the kernel. About a third of the problems that I run into is stuff randomly breaking if I turn off the MMU. Some of these will also break with the Cortex-M3, but some of them only break if I have a CPU core that basically nobody uses. Yes.
Then some comes back to that's because not having them used, but that CPU
in a lot of cases, it's the MMU. Because
proper ARM7TDMI guys as well. 100 lines of this is how you.
No, it's not that one. It's a combination of configuration summaries. If you turn them on together, things break because nobody tested that code in the combination.
It's not only support for the core, isn't it? Right?
No, the architecture.
What about taking an ARM7TDMI reference platform and making it work in the training?
Well, it's currently working. It's just the only one that's working at the moment is the one that we want to get rid of for other reasons.
Yeah, but I mean, usually the no MMU platforms are incomplete.
This one is actually complete.
Okay, but we need more. Maybe if we had more, people will just use it instead of grabbing that old 2.6 kernel that was provided 10 years ago.
Yeah.
Yeah, I read it on this 740.
Yeah.
Does work. Also rewrote.
Yeah.
I think if you want to have people use a mainline kernel, you have to provide them more user space to play with. If you try and find a user space in every Unix system, it's long when you're in for UC Linux.
Yeah.
Designed for 2.4 code, you've got an ancient user space to build.
Yes, but that's a question. Do we care about this enough in Linaro that we actually put work into making Cortex-M3, EFM32, or STM32 work? Sorry?
Getting backing you get is bringing the kernel tree and making it small to be used on the end.
But as I've shown, like the smallest A-class systems, they all have at least 32 megabytes of RAM, and I don't think this perfect shape. Huh? Yeah.
Quite small.
Well, 32 megabytes. Huh?
So if you try to put any user space in, that's become small.
Yeah, but 32 megabyte works really well actually at the moment. There's not a lot we have to do about this.
One nice thing about that is that with KVM, support 32 meg guests.
Yep. Yes, that's very useful. And actually for virtualization, that's one of the reasons when one of my previous jobs at IBM, people were looking into making systems much smaller. So I think they never got below 64 megabytes on the mainframe. But that was a very interesting target. How are we with the time? Are we basically done? Okay. So I've put a number of resources on the last slide if anyone wants to look up the slides. So this is the there's a page about running Linux on small systems in general. Then there's mcraft is the company that's maintaining the 2633 kernel, and they have like a dozen of SoCs they support in there.
So one last comment. People may not be aware, unless you read LMVM.net, there was discussion at the last kernel summit on kernel tinification, and right now it looks like some people at Intel are leading the battle to kind of revive the Linux tiny patches. So that's just a size issue in general. I'm not sure what their actual target is, what they're up to. So that's just an FYI.
I think one of the main interests there was using Linux as a bootloader.
It might be.
Yeah. Because that's something that seems to be popular. PowerPC is doing that on the latest.
Yeah, using it on ARM7TDMI and bootloaders.
Oh.
And that's an interesting use case on all platforms.
Yes, getting the firmware out of the way, getting proper bootloader and that under control.
But anyway, there will probably be, as near as I can tell, there will be revived interest in shrinking the kernel. So.
One of the problems is that a lot of people throw out this 9 billion number for IoT devices and start tying that into Linux. You look at exactly, those aren't where the numbers come from. 5%. Yeah. And you take something like electric vehicle, right? Commercial product flows, they're on ECOS, or they hacked up on STM32. It's 128K.
Mm-hmm. But then a lot of them are using Linux. Like you can have a Wi-Fi controlled power socket that has 32 megabytes of RAM and run Linux on Linux, and it costs less than $5.
Yeah, this is an ARM.
Yeah, right.
A turnkey thing, it's a real product.
Mm-hmm.
Not the development. So you're talking 128K that have a turnkey product to develop things. We're not even going for that. It's not feasible.
Yep.
256K is something that's hacked up on the truth. So you need to choose your paths, right?
So where do you think the boundary should be? What's the smallest system in your mind that we should care about?
I just want to point out.
Yeah, right, but
there's a cutoff. There's a useful function.
Oh. Yes. So you think 5%? So what do we need to do to make that number larger as Linux developers? Yes, but why should we settle with it?
You need to think about roles, right? The home hubs and so forth, right? That's an obvious target.
Oh, Linux is not only an IT gateway thing. I mean, it's not work on that.
There are cars that got Linux running to display 2 months, right? So Linux will go everywhere. You know, it's where you want to put the effort. I put the effort in that. Top ones who want to do it seriously and get good power, good battery life. Minimal system. Then squeeze it down. So it's the SRP thing that makes the cost go up.
Yeah, the only way that we're going to see real traction on trying to do this stuff is if there's a product that really needs it. And until we've got an actual solid use case that can drive, or a couple of use cases that all want the same thing, it's fun to talk about, but I really don't see there being any traction on it.
Well, yeah, there's got to be something that Linux has that the micro hard drives can't do or won't do effectively. Right now, it's like,
oh, we have some.
The interesting thing is how to get the networking stacks to be really low power and in the same way as embedded systems. Things so.
Well, one of the problems with the really small systems is none of them has a proper IPv6 stack. So basically,
they don't want that for an Internet of Things device. They don't want that for an Internet of Things device.
But you can't have 7 billion or 9 billion devices if you don't have IPv6. It's like essential.
Your IPv6 stack is already blowing your rent budget, so yeah.
It depends on your architecture too. It's just a Wi-Fi. It's simple route. They don't care. It's just because you have another device inside your home network.
But behind that.
Yeah, most of the stuff, they're on the internet only, and they just behind a firewall, that's it.
been running for a year, I'm happy with that, so.
I really think you should take a look at tinyos.net. Okay, they have a complete IPv6 stack on their system.
Yes. So a lot of those artists have what they call a complete IPv6 stack, but there's different levels of completeness.
If we're gonna make a list, look at content.
Yeah, that's I was looking through the list on Wikipedia, and there's like hundreds of them. I had a hard time finding the ones that matter.
I'll put you with one paper, reference 19. It's about audio is complete.
Yeah. Okay. Well, thank you, everybody, and we'll have lunch now, I think.